Okay. So we have many circuits here, and in different circuit, all the circuit, we have to determine the current, level current, and the voltage. So the first one, we have a minus 2 volt and minus 2.5 volt. Okay. So first of all, let's see if individual diodes, silicon diodes, are forward biased or not. And silicon diode and germanium diodes are connected parallel to each other, and that they are oriented in the same direction. But whether it's individually, if they are forward biased or not. So for that, what I'm going to do, I'm going to apply Vp minus Vn rule. So for silicon, it should be Vp minus Vn should be minus 2 minus 2.5, 0.5 volt. So what does that mean?
So reverse biased.
For silicon, it is less than 0.7 volt. So that means the silicon is anyway off. So that means this silicon diode is anyway off. And same applies for a germanium diode. If you apply Vp minus Vn rule, we're going to get 0.5, which is 0.5, which is clearly greater than 0.3 volt. So germanium diode is on. So that means, so we find the in the circuits, if we draw the circuit this way, any terminal voltage is measured with respect to ground, 2 volt. From 2 volt we have resistor, and then the silicon diode is off, and then we have the germanium diode 0.3 and 10K. We can determine the current. So I can determine the current. Oh, sorry. Also, I made a mistake. Okay. So there should be another voltage source. 2.5. So now if I apply KVL, plus minus plus minus plus minus minus plus. If I apply KVL, then we get minus 2 minus 10I minus 0.3 plus 2.5 equals to 0. So from there I can determine the current. So I'm not going to do that. I will leave it to you to do that. Now, what is the terminal voltage V? So someone else said that what is the terminal voltage? What should I assume? He said this is the V. I don't know the polarity. So I already answered that. If you notice, V, always assume it to be positive. So we consider V is positive. So that means this is our V. And how are you going to determine V? So for that, I have already mentioned during the lecture that for that, I'm going to start a KVL starting from the ground till this point where there is a V. So if I start making KVL from here. So we get from the ground, which is we get minus, since I'm going from positive to negative, so I'm dropping. So minus 2.5. Okay. Then minus to plus 0.3 is equal to V naught. So this way, V naught or V, in fact, V equal to minus 2.2 volt. So notice we got minus 2.2 volt. That means, in fact, the voltage here is negative 2.2 volt, but we assume it to be positive. Understood? Any question? Any confusion? Are you there?
No, sir, no question, sir.
Okay. So the next problem, তার মানে হচ্ছে কি what I did first, I could apply the rule, তাই না? I could always apply the rule. So okay, silicon diode and the germanium diodes, they are parallel to each other, but they are dissimilar type. Therefore, silicon diode will survive. The germanium diode will survive because it requires lower voltage to turn on compared to silicon. But no, I did first thing I did was to check if individual diodes are forward bias. For example, instead of minus 2. If you have minus 3 volt, তাহলে কি হতো? এখানে কি হতো? minus 3 volts, তার মানে কত হতো? 1 volt. So that means if it is 1 volt, then we could easily say the silicon diode appears to be on. Okay, so individually silicon diode is on, also germanium diode is also on. Then we can make the comparison. Okay, so silicon diode appears to be on and the germanium diode appears to be on, and both of them are parallel to each other. However, we know that two dissimilar voltage source cannot be connected parallel to each other. In that case, the diode that requires the smallest voltage to turn on will remain on, the other diode will be off.
So what if the voltage was 2 instead of 3? What would happen then?
Here, 2.
Yes, sir. Instead of 3, there's 2. Minus 2. Minus 2.
Okay, do that. So we get what? Minus 2 minus.
Oh no, sir. Plus 2. 2 minus 2. মানে যখন 0 হবে আর কি।
Plus 2. Yeah. So in that case, minus the plus 2. So plus 2 মানে হচ্ছে minus 4. So minus 4 মানে হচ্ছে it is less than 0.7. Also for silicon, less than 0.3 for germanium. So that means it is off. Okay. So for both, so if it is 2 volt, so for silicon diode is also off, germanium diode is, because silicon diode is reverse biased as well as the germanium diode is reverse biased. That means if you apply Vp minus Vn rule, we find out that both the diodes are off. Okay.
Yes, sir.
So then the next question, 2 volt, P side voltage Vp is equal to 2 volt and the Vn is equal to 0 volt. And then so clearly Vp minus Vn, which is 2 volt, which is greater than 0.7 and greater than 0.3, which means both silicon diode, germanium diode, and this germanium diode appears to be on. But however, since comparing silicon alone and germanium alone means there is no resistance connected, we find out that the silicon diode requires smaller voltage to turn on, which means the silicon will stay. So we're going to replace silicon with 0.3 and the germanium will stay and the silicon will be off. Then we have what? Then we have the germanium diode with the resistor in series, in this scenario. So 0.3, let's say this is on and resistor and 0.3. So in that case, you know, we made a statement that this happens only when there are only diodes, no resistor, but we have resistor. So if we have resistor, we have different way to solve those problems that we are going to learn our next class. I'll just leave it like that right now. Okay. So the point is that if you have more than one diodes connected to parallel to each other, we could have something like that. Okay, we could have two silicon. So let's say we have two germanium. This is germanium 1, germanium 2. So what will happen to the conduction state of the germanium? এটা কি অন থাকতো, এই জার্মানিয়াম দুটো কি অন থাকতো নাকি অফ থাকতো?
So on থাকার কথা।
No, you see the combined voltage. So let's say we have two germaniums and one germanium. Okay, let's say 1 volt. So what will happen?
Means যেখানে ভোল্টেজ কম লাগবে
germanium will be on.
So that means is you have one germanium, that means that requires 0.3 volt to turn it on. And
Yes, sir.
what is the voltage required to turn both the germanium diode on?
Sir, 0.6.
0.6, sir.
0.3 and 0.3, 0.6. So
0.6
0.6 is greater than 0.3. So that means this branch will be off. Okay. So next question, those questions are similar. So let's do one of them. If you have, so first one, so if you apply Vp minus Vn rule, so Vp is equal to minus 3 volt and Vn is equal to 7 volts. So if you apply Vp minus Vn, Vp minus Vn equals to minus 3 minus 7, which is minus 10, which is less than 0.7. That means the diode is
off.
off. Okay. Now, if I redraw the circuit, I take it here so that I can see it like this. So now I want to redraw the circuit. Yes, so I have to redraw the circuit. That means, first of all, any terminal voltage means it is measured with respect to ground. We have to consider as if a 7 volt source is connected, and any terminal voltage means it is measured with respect to ground. So minus 3 volt means as if. So our circuit is complete. Now, if I do it neatly, you see, the moment you get confused, you raise your voice. ঠিক আছে, যখনই কোনো জিনিস বুঝবেন না, this is your opportunity. পরে, so while you are trying to solve the problem, trying to solve the problem at home, and then you will say, oh, I don't understand, there is no one to help me. So this is how the circuit looks like after completing the circuit. So this is our V and this is our I. Then we already found out what is the conduction state of the diode.
Off.
The reverse biased. Off.
Reverse bias. So we're going to do what? We're going to replace the
Replace it
diode
with open.
Open circuit.
open circuit. Let's do it here. So it is open circuit. What is the current? I is equal to what?
0.
0. Then what is the V naught? The question is, what is the V naught? Now we say that V naught is the terminal voltage. And the terminal voltage, any terminal voltage is measured with respect to ground. So there are two grounds. They're same thing. Two grounds, same thing. So I can measure this terminal voltage either with respect to this ground or with respect to this ground. But the thing is, then you notice, if you start your journey from this ground, Can you reach the point V? No, V.
No, sir.
No. Why not?
Open circuit, sir.
Because it's
Open
broken.
circuit.
It's not complete. So that means I have to go from there. Okay, so I have to go uh, from there. So I'll start my
7
journey,
volt.
from here till that point. You see, I keep on repeating this thing because this is in fact, this is the concept that you learned in DC circuit, but this is where you're going to apply it. And if I keep on repeating, I hope that you'll remember it. So the way I do the the KVL, say negative to positive, and let's say a current is flowing, although we know the current is 0, let's assume that a current is flowing I, and since a current is flowing through the resistor, so there will be a voltage drop, and the direction of the voltage drop is always, current is always positive to negative.
Negative.
So if I apply KVL starting from here, then I get plus 7 volt minus 16I equals to V. And I know that I is equal to 0. So that gives us V is equal to 7 volt. The second problem, again, if I go to this problem, so P side voltage Vp and Vn. So if I do Vp minus Vn, minus 5 minus 5 minus 10, which is again less than 0.7. So diode is off. Now again, if I draw the complete circuit, 5 volt means it is measured with respect to ground, and this, okay. And then if I redraw the circuit, so starting from here, first pole 5 volt, then the diode. You see the order I go from the DC voltage source, the P side is connected to the positive terminal of the voltage source is connected to the N side of the diode. So positive terminal of the voltage is connected to the N side of the diode. And then we have the resistor. Okay. V. I. Again, we learn the diode is what? Reversed biased. So if the diode is reverse biased, so I is equal to 0. And it is 5 volt. So what is V? What will be V?
So minus 5.
Yeah. So again, the rule is that we have to apply cable starting from ground till the point V, and that we can do either this route or through this path. But if you take this path, we get stuck here. We cannot cross the bridge. Bridge is broken. So that means we have to go this direction. So if I go this direction, okay, so let's say I go this direction, again plus minus, and let's say the current is flowing, a current is flowing I. We know that the current is in fact 0, and if this current direction, the corresponding voltage drop plus minus. Now if I start KVL, so we get minus 5 plus 16I equals to B, and then I is equal to 0, so that gives us B is equal to minus 5. All right. So for this one, again, we're going to apply BP minus VN rule for the first one. What is BP?
So plus 5.
Sir, 3.
5. First one, we're talking about first one. BP is equal to 5 and VN is equal to
Minus 5.
minus 5. So if I apply, and then as before, we draw the any terminal voltage means it is measured with respect to ground. So this is our, at the same time we completed our circuit. Also we do BP minus VN. So 5 minus 5 is to 10 greater than 0.7. So that means diode is on. Now if I redraw the circuit, first of all, 5 volt, and 5 volt is connected to the resistor. From resistor we have this V, and from the diode, diode থেকে V, the current is I, so 16K, 5 volt, 5 volt. Okay. So now I know that the diode is on, so we can replace the diode with 0.7. Then you can apply KVL. If you want to apply KVL, what I'm going to do, so always make it a heavy to put the sign, polarity. So current is flowing from left to right, plus, minus, plus, minus, minus, plus. If we apply KVL, then we get minus to plus is equal to 5 plus 5 minus 16I minus 0.7 plus 5 equals to 0. So you're going to get some value of current that I'm not going to do. So next question is, how am I going to determine V? So again, V is the terminal voltage here. And we said that in order to determine in terminal voltage, what we should do, we're going to start our journey from ground till where? Till this point. So now we can see that we can reach, in fact, we can reach this point either from this ground, if we take, you can take path 1, let's say we call it P1, and you can take P2. And either way, you're going to get the same value. So if I take P1, I get plus 5 minus 16I equals to V. And now we put the value of I, you get the value of V. And if this is if we take P1, and if I take P2, so that means I'm starting from this ground and go this point. So what is the first thing that I'm going to encounter? Plus sign. So if I go plus to minus, I can write minus 5, minus to plus, plus 0.7 is equal to V. So in fact, which one is the better one?
So P2.
P2, because you can straight away get the voltage. So in fact, you would get the same value. But in that case, what you have to do? I এর value টা বসাতে হতো. So that means whenever you have multiple routes to obtain any terminal voltage, so you would prefer the one where you could get the straightaway voltage, no resistance. The second problem, again VP is equal to this, and VP is equal to.
Sir,
Yes.
if I write V equal to plus 4.3, is it correct?
No, V is equal to minus 4.3. DC minus 5 plus 0.7 is V. Is that all right? Still confusion?
No, sir.
Okay, so Vp is equal to 3 and Vn is equal to minus 7. Again, any terminal voltage means it is measured with respect to ground. It is measured with respect to ground. And if we apply minus Vp minus Vn rule, we get Vp minus Vn, which is 3 minus minus 7, 10, which is greater than 0.7. It is on. Now, if we draw the circuit, complete. So 3 volt, then the diode, then the resistor, then the DC voltage source. Okay, 3 volt, 7. And since we found the diode is forward biased, we can replace the diode with 0.7. And then if in order to determine the current I, we can apply now. I'm not going to go do this one. It's quite simple, exactly same as before. Okay, I will leave it to you. Okay. So let's isn't that a similar problem?
স্যার ফার্স্ট স্টেপটা সিমিলার আছে স্যার, লাস্ট স্টেপটা করলে একটু ভালো হতো, মানে সেকেন্ডটা।
এটা
জি স্যার, জি স্যার।
okay. Again, so let's do it. So our Vp is equal to 0 since it is grounded, and Vn is equal to 5. So if you apply Vp minus Vn equal to 0 minus 5 less than 0.7 reverse bias. And then any terminal voltage means it is measured with respect to ground. So I draw it. And this is all anyway grounded. So if I complete it, then the resistor, okay, and then the diode. This is how the circuit looks like. It's a 5 volt R. Now found out the diode is off, so which means I can replace the diode with open circuit. So open circuit. So that means I is equal to 0. Now what will be V?
So 5.
5 volt.
+5.
Yeah, but be careful. There's plenty of student, and actually I would say that there is scope for confusion. Though many students would say, okay, B is equal to 0, and that's the thing. I would say many of you will be thinking right now that V is equal to 0.
স্যার তাহলে স্যার ফার্স্টের যে সার্কিটটা আছে ওখানে ডায়োডের ভোল্টেজটা বলছে, ওটা যদি অন হয় তাহলে সিলিকন ডায়োডের স্যার
Sorry,
ফার্স্ট
sorry.
একটা স্যার ফার্স্ট একটা
This one.
জি স্যার এখানে
Yeah.
মানে ডায়োডেরটা বলছে তাহলে মানে স্যার জাস্ট 0.7
Yeah. So whatever the voltage you see.
ওকে স্যার
Okay.
Yes, sir.
So someone would say V is equal to 0. It's wrong. So V should be 5 volt. But how do we get this? Again, we said that any terminal. So best way to do is that just simply follow the procedure. What is the procedure? We learned that if you want to determine any terminal voltage, we're going to start our journey from where? We're going to start our journey from the ground. So we start our journey from the ground. So we take a journey from the ground and follow the path till that point. So if I do that, considering current is flowing in this direction, if I get plus 5 minus IR is equal to V. And then we know that I is equal to 0. So this way, 5 volt. And this first one is that. So first one, Vp is equal to. So if you like, let's do Vp. Vp minus Vn is equal to 10 minus 0, 10 greater than 0.7. It is forward biased. So diode is forward biased. Now if you can replace the diode with 0.7. If I draw the circuit, okay, you can determine this. It is our 10 volt, 5K, and 0.7. So again we say that if you want to determine V, so what do we have to do? We have to make a KVL starting from ground to this point. So if we start a ground, make a KVL starting from ground to this point, what are we going to get? We can take this path or this path. Let's say P1.
মানে স্যার একটা দিক দিয়ে এখানে মানে একটা দিক থেকে গিলেই হবে পাঁচ
যেকোনো
বা
একটা। So I'm just going through an elaborate way so that you know the steps. So if I go for P1, then it will be
ওকে স্যার
plus 10 minus 5I equals to B. And if you go P2, you will get plus 0.7 is equal to V. So that means whatever the steps you take, you're going to get 0.7. So since this one appears to be simpler, we're going to follow this path. So this is our P2. So next question, consider the meter indication for the following circuits. Determine if the diodes are on or off. Okay, tell me the first one. So we have a circuit. Okay, the voltage source 15 volt, then the diode and two resistors 10 ohm and 68 ohm. And they said that consider ideal diode model. In ideal diode model, we when it is forward biased, we consider the diode is short circuit. Now we find the voltage across the diode is what? In this case, what is the voltage across the diode? 15. So what does that mean? Is that if we apply KVL, let's say if we apply KVL, okay, around this circuit, so we get plus 15, and then let's say current is I. Then the voltage drop across the diode is what? Also 15. So this is plus minus, that is minus 15 minus 10 plus 68, 78
I goes to 0.
So minus 15 plus 15 goes away. So that means I is equal to 0. So I 0 মানে হচ্ছে কি? ডায়োডটা কি আসলে কি?
So reverse bias.
Reverse bias. Diode is in fact off. So diode, what is the conduction state of the diode? Off. So by
Off.
looking into the value of this, we are asked to determine the conduction state of the Diode is off. Same way, if I, we are asked to determine the conduction state of the diode. Tell me, what will be the conduction state of the diode?
On, sir?
How?
Sir, if you apply the KVL,
হ্যাঁ
so KVL apply করে স্যার আশা করি না।
আচ্ছা
So এটা পারি নাই আর কি, অনেকটা মানে
আচ্ছা
কনফিউজ
কোনো
হয়েছে।
সমস্যা না, অসুবিধা নাই। You see if what is the voltage drop across the resistor?
So zero.
Zero. So how do we determine the voltage drop across the resistor? IR, তাই না?
Ohm's law, yes sir. I am.
IR is equal to what? What is IR? What is the IR here?
So zero. তার মানে কারেন্ট is zero.
Current is zero. If the current zero, which element is open?
Oh.
There must be something open.
Yes sir.
Okay?
Yes sir.
The diode is open. The diode is open. So which means the diode is open. For example, instead of 0 volt, you get some value of current. So let's say I is equal to, let's say I equal value পেলাম we find say এখানে V পেলেন কত 12 ভোল্ট। যখন ভোল্টেজ 12 ভোল্ট পেলেন তখন কি হবে?
So 12 to কাটা যাবে মনে হয় নাকি?
Something like that. 12 volt. Actually, it's not possible. In fact, the diode is reverse bias. So diode is reverse bias. But if it were like that, let's say let's do a problem something like that. Okay. We have a DC.
স্যার এমনিতে তো স্যার প্রথম দুইটাতে আই শূন্য, তার মানে দুইটাই ওপেন সার্কিট।
Open circuit, হ্যাঁ।
আচ্ছা স্যার।
And let's generate one problem myself. Let's say we have 10 volt, okay, and we have a resistor, and there is a black box which contains diode or diodes. And the current resistance is 1K, and the voltage drop across the resistance measured, so let's say the emitter measured 8.6 volt. So defined. Okay, first of all, we determine the current. So determine the current. We know the current is equal to IR, which is 8.6 volt, and R is equal to 1K. So I is equal to 8.6 divided by 1, 8.6 milliampere. So that means a current is flowing. A current is flowing. So if the current is flowing, there are diodes which are on. And considering silicon diodes, so what is the voltage drop between this? Voltage drop between this is that, let's say voltage is Vx. So we can find out if we apply KVL. So plus 10 minus 8.6 minus Vx is equal to 0. So that gives us
1.4.
Vx is equal to 1.4. So 1.4 আসলে কি মিন করে?
মানে
0.7 plus
দুইটা সিলিকন ডায়োড,
7.
দুইটা সিলিকন ডায়োড।
Two diodes in series. Duita diode in series. That's what it. Yeah. Okay. So 10 volt and 1K and silicon. Let's say D1, D2. Both of them are silicon diode. Okay. So next problem. Determine the terminal voltage A, B, C, D. Consider practical diode. So determine terminal voltage in this point, in this point, in this point, and in this point. So again, we can apply. So what condition we have? We have DC voltage source and diode and resistor in series. So that means we can apply Vp minus Vn rule. And there are two diodes. And if there are two diodes, so Vp minus Vn must be greater than 1.4 to be on, less than 1.4 off, and equal to 1.4 transition state. Okay. So let's apply. First of all, Vp is equal to, this is P side voltage. So Vp is equal to 25 volt and Vn 8 volt. So if we apply Vp minus Vn, 25 minus.
স্যার 8 ভোল্ট হবে না -8 ভোল্ট হবে?
No, you see the terminal voltage, N side voltage, terminal voltage. So you just apply KVL starting from ground. So what do you get? Let's get this is our Vn.
না স্যার,
Let's
ভ্যালু
say this is our VP.
-8 দেওয়া আছে, এটা বলতেছি।
Sorry?
স্যার ভ্যালুটা -8 দেওয়া, পজিটিভ সাইডে -8 দেওয়া।
Minus 8 না, polarity দেওয়া আছে, minus
ও
plus.
সরি,
Minus plus, polarity দেওয়া।
ওকে স্যার, সরি স্যার।
Minus 8 na. Don't get confused.
ইয়েস স্যার,
ঠিক
ইয়েস
আছে?
স্যার, থ্যাংক ইউ স্যার।
So that means we have 13 volt, which is greater than 1.4 volt. So that means both the diodes are on. If both the diodes are on, we can replace both the diodes with 0.7. অসুবিধা নাই। So this is how the circuit looks like. Okay. So 25, 0.7, 0.7, 1K, and 8 volt. And let's say the current is I. If I can determine the current, so minus, plus, plus, minus, plus, minus, plus, minus, plus, minus. So plus 25 minus 0.7 minus 1I minus 0.7 minus 8 equals to 0. So from there I'm going to get I, which I'm not going to calculate here. তারপর কি বলেছে? We need to determine voltage at A, then B, then C, then D. Acha, A and D is very easy. Why? Because we already learned that in order to determine any terminal voltage, all we have to do, we have to start from ground and then go to the corresponding terminal. So let's say this voltage is VA here, this is VB, this is VC, and VD. And if from there, for example, if I start from here and go up to that, So that we get, so plus 25 equals to VA. VA is equal to 25 volt. Similarly, for D, what we have to do? Start from here, go up to this point.
Plus E.
So VD is equal to koto?
Plus
8 volt.
E, yes.
8 volt.
Acha, now, in order to obtain VB, so what do we have to do? Again, start from ground and then go up to VB. So that means we have to go. So this is the path we have to go. Let's say P. Okay, let's call PB. We call it PB, path B. So starting from ground, if you go from up to that, so if you go, you apply KVL, plus 25 minus 0.7 equals to VB. So that means we get VB is equal to 24.3 volt. So that means with respect to ground, I mean ground থেকে যদি এই terminal voltage measure করি, then I'm going to get 24.3 volt. And then let's say we want to determine VC. So VC, for that, what I have to do? I have to start. I'm going to take the path, let's say. PC. Starting from ground, I have to go till that point. So if I go, I get plus 5 minus 0.7 minus. Now I have to pass through a resistor, and there is a current flowing through these resistors, and there is a voltage drop, and this voltage drop would be minus. Since I go from plus to minus, so minus
Minus 1I.
1I equals to VC. Now we already know the Is it all right? Can you mute it? So I got VC.
Yes.
Now,
sir.
interesting thing is that you could also obtain VC if you go this way. If you let's say if we take this path, so VC prime. If I take this path, what do I get? So starting from here, okay, starting from here, say VC prime. Take this path.
So
Going from low
plus
to high.
E.
Plus 8 plus 0.7 is equal to VC, which means VC is equal to 8.7 volt. So this is how we are going to, now it's all the terminals, all the point A, B, C. So this voltage is measured with respect to ground. This voltage is measured with respect to ground. This voltage is measured with respect to ground. This is how we can measure the terminal voltage. All right. Any question? Any question? So if we don't have any questions, we can call it a day. I'm stop recording it.